210. Define the term orbital velocity and the quantitative and qualitative relationship between orbital velocity in terms of the gravitational constant, mass of the central body, mass of the satellite, and the radius of the orbit using Kepler's Law of Periods. So when Johannes Kepler studied the movement of planets around the Sun, he discovered that there was always a mathematical relationship between the period of the orbit and its radius. So when its radius r cubed is divided by its period t squared, it is a constant. Now this means that for every satellite of the Earth, it has the same value. So its radius divided by its period will give the same value. So Kepler of Law of Periods was discovered empirically. That is, it was discovered by observing the motion of the planets, but Kepler had no idea why it was so. When Isaac Newton developed the law of gravitation, he was able to prove that his theoretical basis follows this image below. So you got centripetal force equals gravitational force. And the key thing here is you can see that the mass of the satellite disappears, and you don't need the mass of the satellite. So when you insert both of the equations together, centripetal force and gravitational force, you can see here that it's rearranged right at the bottom is deemed as Kepler's Law of Periods. So you got the radius cubed over the period squared equals gravitational constant over the mass of the planet divided by 4 times pi squared. Since the right-hand side are all constant values, this proves that Kepler's laws and establishes the force of gravity as a controlling force for all orbiting satellites, including the planets around the Sun. So orbital velocity is the velocity given to keep the body in orbit, okay, when I've referred to it in the video.